The point of Chromia, the goal of Chromia is to help people to make decentralized applications which actually work and to reach mainstream users. So this means that applications, they need to work in a way which users expect. So users expect fast basically response times. They expect it to work like a normal web app. They don't want to wait when fetches data, or they don't want to wait confirmations. They don't want to know what is gas and how much gas they need to pay to do some actions. They don't want to be charged for each action, of course. And also we want to make it very easy for developers to make applications, or at least easier than it is now, which means that we want to have everything in as a single, basically, Chromia includes pretty much everything you need to build an application, so you don't need to build applications from bits and pieces glued together. We have integrated development environment based on Eclipse, where you can build the entire application, deploy it, and so on. So we give convenient tools, and we also give very better programming language, which integrates relational database features, which developers are used to, and they can basically build applications in a much easier way. So it usually, like for me, it takes like if we take like sample application, like let's say decentralized exchange or token. For me, it takes like an hour to build a backend for this application. So it really is quite easy. Of course, like might take some time to actually learn the platform, but we make it basically as simple as possible. So let's cover a little bit of history. So I'm the lead developer of the project. I have been doing blockchain research for 8 years, and I was lead developer of Colored Coin projects, which made the first user-defined tokens on the blockchain, first decentralized exchange, back in 2012. Many people prominent in the blockchain space now were involved in that project. For example, Vitalik Buterin or Jimmy Song, and so on. And our company called Chromaway. It was founded to commercialize the blockchain and colored coins 5 years ago. And one of our first project was a mobile wallet based on colored coins. And what we found that current tooling is not really adequate even for doing payments. So for example, Bitcoin Node software, Bitcoin D, it doesn't really help you to deliver information to mobile wallets, to mobile. So basically, users expect then when they open a wallet, they will see how much money they have now, how much money they received. And it takes a lot of time to parse the blockchain, of course. So you need a blockchain indexer. And we have been using like many, like maybe 5 different blockchain indexers, and they all of them had some issues. So in the end, we created our own Bitcoin indexer, which used relational database. We put basically all Bitcoin data in SQL database, so we can query it very efficient manner, and to assure that the synchronization is very fast and it always correct, so it doesn't basically lose anyone's transaction, show something which didn't happen. So it takes some basically effort to handle, how do we handle reorganization, for example, and so on. So we basically, that's where we got the idea to use relational database. And later when we started planning more general blockchain framework for any kind of application, not just tokens, but pretty much anything. So we thought, what do we use for storage? And we decided that it would be best to use relational database. Relational database, it can do everything which key value store can do, of course, but it can also do indexing. It also has transactions. So that way you can build just one piece of software which kind of encodes blockchain logic and also performs the indexing. And that means you don't have to build a separate indexer to actually serve mobile clients or like light wallet users and so on. And initially we made this framework targeting just permission blockchains, like enterprise blockchains, but later we found the opportunity to bring this technology to public blockchain space, because in the public blockchain we saw that there is no good tooling basically, and yeah, for the public blockchain it had to be like use more complex architecture. Like we have each application its own blockchain, and we have software like components which orchestrate running these multiple blockchains on different nodes to make it scale. And we had to create our own programming language to make basically still benefit from fast queries enabled by the database, but at the same time restricting what application developer can do, in the sense that so he doesn't crash node software or anything like that. So it's a little bit about limitations, what we're trying to others. I already mentioned indexing. So basically currently when people build decentralized application, they have separate indexer working with their like contract, and this indexer is typically centralized, or at least it's not connected to the blockchain. It comes with no guarantee that the data served to user is correct. So what is the point of the centralized application if it relies on a centralized component? So basically I think it's not a properly decentralized application. So we need to, if we want users to be actually connected to the decentralized application, we need it to have built-in indexing so users can retrieve this data directly. Another limitation, of course, resource cost. So currently what we have, like Ethereum and US and so on, it might be sufficient for applications which deal like financial applications, when you have transactions with like $1,000 value, and you can pay fees on that, of course. But for more like other kinds of application, let's say you want to build like decentralized social media, it's not really like current blockchain doesn't address it, and people usually common wisdom is that these applications are not meant for blockchain. But how do you do decentralized messaging which doesn't lose your data, which basically is actually usable? So basically how we address it is that we have horizontal scalability. So each application gets its own blockchain. Actually, application can run multiple blockchains, and they're spread among nodes. So more nodes we have, more applications we can run. And using this basically approach, and different providers, they contribute these nodes, and there is competition. So if a provider charges too much, his node won't be selected. And this creates basically operational providers to offer a fair pricing for resources. So basically it should be in theory be quite close to what cloud vendors provide. So if you can run application in cloud, maybe it will be slightly more expensive on the blockchain, but same order of magnitude probably. Yeah, and of course, there is a trade-off. So this model, we cannot run like 10,000 nodes having the copy of the application. We assume the model where user typically has a mobile wallet, so he only gets a copy like of what information he needs. But the application is decentralized, like it's run by multiple independent providers. So usually there are like most blockchains like Ethereum, Bitcoin, they have only like 5 or maybe 10 pools producing blocks, so we can have same number of block producers in the system. So basically it will be decentralized in that sense, but not in the sense that every user validates all the data. Of course, users, if they really want to validate, they can have a copy of blockchain as well. And another problem which arises very often is that it's hard to upgrade applications. So of course, like application needs to evolve over time. It's not like people cannot come up with complete application in just one go. They get feedback, but it's very hard to upgrade application when your data, it's like, for, let's say in Ethereum, you have immutable contract and your data is tied to that contract. So you cannot upgrade the contract. You can, of course, deploy another contract, but you already have data in another contract. So we handle that by decoupling, basically, by using relational model. So basically data is in this relational model. It's somewhat separate from the logic. So you can upgrade the logic without keeping the same data. And you can also kind of enhance the data. You can add the things to the model, just adding more relations, more objects, but still keeping the old data intact and upgrading application in this way. Of course, application cannot be upgraded at any time. So basically, but yeah, that's more complex token. So it's a bit okay. So relational database. So basically, I think some people nowadays think like use NoSQL, like a relational database as a kind of dated concept, but I think it's more like a timeless concept because it's based on a very solid mathematical foundation, like algebra, relational algebra, and so on. And I think it's like a very good way to structure a data model, since you can think first about what kind of objects you have and what is the relation between this object, and then the data model arises from that. So that's very flexible, and it allows certain guarantees, for example, like constraints. So for example, if object is connected to other objects, it shouldn't be deleted if it's basically referenced. So if application has a bug, relational model itself can prevent application from having this bug. Basically, then of course operation won't be performed, and developer can upgrade the application. The architecture of this is architecture of the node, basically, not like we also have separate architecture of the system with blockchain, I mean side chains and so on. So, but this is shows architecture of the node. So basically, it's very similar to other blockchain nodes like Ethereum and so on. It doesn't really do any crazy stuff. So basically, you still have transactions signed by users, validated by nodes, consensus based on PBFT-like consensus as the first layers, and we use anchoring and like higher basically degrees of consensus. And we have models, so basically what people call smart contracts or chain codes, we call it models. So basically each blockchain has its own model, and actually it can actually read data from other blockchains on the same node. And API is probably something which differentiates from some of the projects like Ethereum, is that each node directly provides clients, like mobile clients, to query data using API and to send transactions. So like application itself, it doesn't, it basically just uses Chromia. It doesn't have to run any other blockchain nodes, like Chromia nodes. They are already designed to serve directly the users of the application.